Hello, everybody. Welcome to today's partner breakout session. Thank you guys for joining. My name is Stephen Rauner. I am the partner solution engineer that's here at Knime. And today I'm also going to be joined by Stefan Pacinda from H2O. Stefan, if you want to go ahead and introduce yourself.
Hello, my name is Stefan. I work at H2O as a solution architect, and my mission at H2O is to help our customers adopt machine learning and automated machine learning in the first place.
Cool, awesome. Cool, so once again, welcome to the session. Today we're going to go over harnessing H2O.ai with Knime to reduce your machine learning development and deployment times. So for anyone who attended the main session today, we had a brief introduction to how this new partnership the extended partnership between H2O and Knime has included their new driverless AI functionality. So what we're going to go ahead and do is show basically an end-to-end workflow combining Knime, the integrated deployment functionality that was introduced yesterday, and the driverless AI integration all together in one data science package. So before we jump into the demo, just a brief introduction. You guys are at the Knime Summit, so I assume you know Knime and about us, but just a brief introduction. We're out of Zurich. I'm out of the Austin office, out of the US HQ. We're an open source community with server products. And then H2O, for anyone who's not familiar with H2O, their headquarters in California. They've been around for about 8 years, and they're also an open source community similar to Knime, which is being used by over 180,000 data scientists. So as I mentioned before, Knime and H2O have been partners since 2017. We already have a few H2O extensions in the Knime AP, which is going to include their H2O3, their Spark integration, Sparkling Water, and then other extensions. So what we're going to go over today is the new extension, which is just driverless AI. Cool. So just to give a frame of what I'm about to go through, I kind of like to start at the end sometimes. So what I'm going to do is I'm going to use Knime and integrated deployment to build a model and basically wrap it in endpoints where I can hit it with new information. So what's happening here is we're pulling in information as credit card default information. So we have demographics about the customer, information about their payment history and their billing history, and whether or not they defaulted on any payments. So what we're trying to predict in this scenario is if we have a new customer with this kind of history, should we maybe approve them for a credit card, or should we keep an eye on them? So at the end of the day, what we want to do is we want to take validation data, which doesn't have the flag on it, so it doesn't have any kind of default information. And what we want to do is we want to apply the model we created to it and just kind of as a service, right? So where I can hit this, this table on my server and get a response. So now, after sending the data to that particular workflow, I now have a prediction of whether or not they will default and prediction values for each of the two classes. So prediction of default equaling 1 and equaling 0. Cool. So now to kind of rewind and go, how did we get here and how did we build this? So what we're going to start off with is kind of the master workflow. And this is the one that's going to be making the modeling, and it's also going to auto-create the deployment workflow as well. So what's happening here is, let's say I have historical information coming from different sources. This first box is going to be essentially all the data input. So what I'm doing is pulling one data set from Amazon, pulling one CSV from my machine, and also connecting to a database and pulling 2 tables from there. From there, we can join all the tables together to make this master data set. And so now, and one kind of pretext in this workflow, there's a few different sections. And every time you see the purple section, that's going to be what we use the integrated deployment nodes to pass to the next workflow. So these are the steps that we know are going to be done again when we actually have the real data coming in, right? So like, for instance, all this pre-processing we're doing, right? Like going through applying missing value conversions. In this case, we're doing a numeric binner to take age, and instead of having it as a continuous variable, we want it to be categorical and put it into 3 buckets, essentially: young, middle-aged, and mature. Filtering out the columns we don't need. So ID is too specific, so we're going to get rid of it. And now age is very correlated with the new age bin we just created, so we're going to get rid of that as well. And then just restart it just for aesthetic purposes. So the reason we're using these integrated deployment nodes here is because we know that the new data is going to come in as the same format as this data, so we're going to apply the same pre-processing steps to it. From there, we get into the actual model creation. And what we're doing here, so there's a few steps happening here. First off, we're taking that data, so all the historical data we put together, doing all of our pre-processing, and now we're going to do our test train split, right? So on our training branch, this is where we're going to invoke Driverless AI. And from here, we have these 2 nodes that can audit, and this is how we're going to automate the process of making a model through Driverless AI. So the first node is going to be the process of sending this curated data into the H2O Driverless AI instance. And the second node here is going to create an experiment from that data. And there's a few parameters when you're creating an experiment, but when I pass it over to Stefan, he'll go into much more detail about what's happening behind the scenes. And then once we have the experiment back and we have this new Mojo object is passed back to us, we're able to use that Mojo for predictions, and we were able to score a service or just have a model in general. So before I go into the next step, I'm going to actually pass it over to Stefan, and he will go ahead and show you what's happening on the Driverless AI side. So.
Okay. Thank you, Stephen. So let me share my screen real quick. All right, so this is Driverless AI, and this is where the journey continues. So we have seen Stephen prepare the data, do some data pre-processing, splitting the data into train and test, and then kicking off an experiment. So if I start from where the workflow currently finished, you can see I was not fast enough. So this particular experiment is the experiment that was created by the workflow, and it has already finished training. So let me see what I can do from here and describe you what the end process looks like. So this is my experiment finished. You might wonder why it's called an experiment when we are trying to build a machine learning model, essentially. So throughout the process of building the final model that we are happy with, and that's the best performing one that we can come up with, we built a number of other models and do a lot of stuff that altogether we call an experiment. So what are those steps that happen? First of all, we are trying to find out the best set of algorithms for our model. Based on the input data, then we find out the best settings of those algorithms, and later on we take the data in the way that was passed into the model, and we try to represent that data in such a format that helps the standard machine learning algorithms perform the best. If you're trying to come up with new features, with new columns of your data set in a very creative way, and build more and more models to test out whether this has actually helped or not. And this is actually a very lengthy process, and this is what Driverless AI automates for the data scientists. So this was the experiment that Stephen has kicked up, was with the lowest settings possible, with the lowest accuracy time and highest interpretability. So that's the really the most simple model, and the data set also is not very large. But you can see that this is the experiment this is the experiment summary, where you can see that um, throughout this experiment, we have in those 20 seconds, we've actually trained 9 models for the final pipeline, 6 models during the feature engineering. And well, if the settings were much higher, we would be probably training dozens or hundreds of models and testing out hundreds or thousands of features to determine the best feature set for our model. Now, when we determine the feature set, we train the final model, which based on the input settings would be very often an ensemble of the of several best performing types of models, and package all of that into an object called Mojo that we would send back to Knime. And that Mojo object, you can actually manually download it here. It's called downloads Mojo scoring pipeline. That command that you can invoke. And that is basically essentially a file that describes the way how to create all the features needed for the model to perform well as descriptions of all the algorithms, their settings. So basically, it's a prescription for a scoring engine to generate the inference or predictions at runtime. This all is entirely disconnected from the driverless AI server, so you can embed that nicely into the workflow inside of Knime and do not need to communicate with driverless AI server once the model has been trained. Now, let me now take a step back, and there is also another process that can be employed from within Knime. So as you have seen, Stephen has prepared the data set, and the first step has uploaded the data set. This is actually where you can carry on directly from within Driverless AI. Stephen will later show you that there's also an embedded view inside of Knime. And let me show you how you would maybe spend more time developing the basic model until you find out that this is exactly what you want to automate, and then automate the whole process within Knime. So this is basically the landing page, and I'm seeing the set of data sets. So this is the automatically named data set with the unique name encoding when and how it was created. So let me have a look at the details of the data set. So this is something that Stephen has already described. So we do have some demographic data, some payment history, billing history, etc., and our aged bins feature that we've created in Knime. I can have a look at the data. So far so good, and we are trying to predict this default monthly payments. So you can see that it's slightly imbalanced, but it's nothing to worry about. Next step that you want to do would be looking at the data in more detail. So for that, you can click on Visualize, and Driverless AI would automatically create a bunch of visualizations and a bunch of charts for you. So what actually happens is there's a long set of statistical experiments that are being conducted on the data set, and those methods that show some relevant results would end up being described in one of those charts. So let me just have a look at correlated scatter plots. So for instance, here you can see that bill amount 5 and 6, which is the amounts due on the account, is heavily correlated in the 2 following months. That makes a good sense. You can have a look at skewed histograms. So should there be some skewness in some of the columns, you're able to spot it out here. For instance, disparate box plots. What is interesting is maybe outliers. So you can just have a look and look at each of the outliers on each of those of your columns, and just reason about whether this is actual outlier, or you maybe want to come back to Knime and do some more pre-processing later on. That's also a correlation graph that allows you to inspect the correlations and their respective strength and many-to-many fashion. Also data heat map that allows you to see the structure in the values in your data set, and much more by adding a custom plot. So I'm able to okay, let's do something better. So maybe a quantile plot on, and what I'm going to look at is maybe have a look at your education and obviously y-axis. Let's have a look at default payment next month distribution. And now I'm getting a custom plot here, and you can have a look at the distribution based on. So this is a discrete value education, and this is your target. So you can see what are typical values here. We could spend much more time there, but let's go back to the nitty-gritty of what Driverless AI is really good at, and that's building models, and very accurate models fast. So this is me looking again at a set of data sets. So I'm now going to click on predict, which allows me to set up an experiment, just like Stephen has done from within Knime. I'm going to select a target column here, which is my default payment next month. And then let me just manual experiment. And now there are a couple more things that I can do. So I can be a copycat and drop something, but Stephen has already filtered the unused columns for me. There is a possibility to use validation data set, but Driverless AI is using actually a very strong reusable holdout cross-validation technique. So we do not actually, and unless really needed, think that it's a good thing to specify validation set, but rather keep everything for the training set. So now the most important values: accuracy, time, and interpretability. So what these values control is how complex the model is going to be, how on spot with the predictions the model should aspire to be, how long it should take to train it. So basically, we are throughout this whole process, if you recall, I was saying that we are optimizing parameters for the model, combination of various feature transformations, adding new ideas into how to reinterpret the data. So that all takes time, and obviously it's an NP-complete problem, so it is not possible to in a reasonable amount of time on some real-life data to test out all the possibilities. So we are having we are using an evolutionary algorithm which allows us to intelligently navigate through this search space. So if you can see that if I increase the accuracy, for instance, the feature engineering, so the feature evolution now has 8 individuals and is going to spend up to 70 iterations. So 70 iterations of building various types of features, and each individual is a complete feature set of new features tried. So if I increase also the time, you will see that now there is early stopping after 50 iteration of no improvement. You can also see that the final pipeline now is a blend of up to 4 different models and averaged on 3 cross-validated splits. So effectively, it's 12 different models. And interpretability, among other things, controls your feature engineering space. So if you lower it, it will just contain transformations that are easy to describe and will. So this is the lowest interpretability. So you can see that's a full feature set. If I just increase it to 10, which is more interpretable, then I'm having monotonicity constraints in place and permutation importance feature set pruning and other things. So I'm going to have an estimation how long it will. Let me just take the most aggressive setting. How long it will take, and my final pipeline would. So this is the number of the models to train, right? So at this point, you should be getting the idea of what we are automating. So we are going to train 360 models. 18,000 try 18,000 features and train 15 models for final pipeline. So even though this experiment ran for like 1.5 minutes in the basic settings, now it would run in hours, and it would automatically do a ton of work for the end user. So if I just lower this down a bit so that we will see it move. Okay, and before I launch the experiment, I'm going to open expert settings. So in expert settings, you have the ability to control everything and anything possible in the workflow. So let me just maybe start by saying something that was not really clear. Driverless AI, what kind of experiment types does it support? So it supports, we call this like the IID, typical normal statistical machine learning, which is what we are modeling as in this example. Then also time series. So this is forecasting, where you have where your data is has a temporal element. NLP. So your one of your columns can be a longer textual column, and also you're able to model a problem, and this is also nicely manageable in Knime, where you actually pass on type of your target class and path to your image file, and all of these types we can of problems we can model. You're able to control which which type of models you may want to use. So if you want something super super simple to interpret, you might just force rule fit or decision tree models or GLMs. On the other hand, you may have reasons to turn on or off your TensorFlow models, etc. There's a ton of parameters for model building tree building strategy and various coefficients and so on. Right. So, but the good defaults are working really well, and just by opening the experiment, just like we've done, and clicking launch experiment, the default values are pretty strong, and they take into account the size of the data, the hardware sizing of your machine, and so on. So I just click on start experiment, and now you will see what actually was happening behind the scenes when if I was faster than I was. So you will see the progression on your left-hand side in the iteration data. So each yellow box is a model that has been built. If I hover over those boxes, I will see the leaderboard of my features. So here's so different features work differently. So you can see that this all changes, and this will be 16 iterations, I guess, based on the accuracy too. You can, throughout the experiment, you're able to read some notifications, which tell you whether or not there has been some data leakage identified or some problems with your data when it comes to distributions, missingness of values, and other things that do not that generally do prevent you from building good models. And also you can hover over this receiver operator curve to see various cutoffs, generating different confusion matrices. That's for you then to decide where's your cutoff and how to use it. You have different statistics, lift chart, gains chart, Kolmogorov, Smirnov. You're able to see how much power you're using. When you're done modeling, you will see insights. You can also see scores. So there's a number of different models that have been taken, that have been trained. So you can see these are the types of models for use in the cross validation faults. Here's your final model ensemble scores for different types of scorers, and so on and so forth. Once this is done, we can also have a look at the insights. With the so I might wait for it a little bit. Okay, let me just skip onwards. So there will be a button that tells me to interpret this model. So I'm just going to fast forward and show you what is the result. So I have pre-computed this. Didn't really take long. It was only 2 minutes. So imagine that your model reached a good score, and now you want to see what were the key drivers and factors behind the model, and whether or not your model actually makes sense in reality. So let me start off by looking at summary. So this summary actually makes sense for you to read once you know what we are doing. So I will start with surrogate models. Surrogate models, the simplest of them all is a decision tree. So surrogate models are models that are trained, that are simpler models that are trained on not on the actual data, but on the predictions of the model we are trying to explain. So first of all, decision tree. So we built a very simple decision tree for you to see a simplified version of the model. So I can zoom out and in. I only have by default trained 3 layers. So you can see that the most important feature is base 0. If I just randomly select row number 1 to 3, then I will see in the gray where for my sample for my customer number 1 on the row 123. So if we didn't drop the ID, I could also search by the ID of the customer. So I can see how this sample went down, and that it was actually not a typical sample, because the thickness of this line tells me that most of the cases, pay_0, which is your attribute telling you whether or not the person paid on time. So negative values or 0 are good. So most of the customers are paying on time. So this person actually was paying late and was consistently late. So it actually got quite a high score. If you want to dig more into more details, you can have a look at Knime. So Knime is a method that, first of all, it divides your samples into K clusters, and then for each cluster plus the whole overall cluster of the model builds you approximations. What are these approximations good at? So I will just select one particular point, and if I click on it, I will be taken to the cluster where it belongs, and actually belongs to the main cluster 0. Let me just select another one, which might be okay. So I just have identified two of the same cluster. Nevertheless, what I'm seeing here is the actual prediction was 1. So this is 1 and this is 0. I can highlight this. So these are the predictions. This is the model prediction, and these are the approximations. So I am able to click on explanations, and with the likelihood of 98%, I was able to tell that my prediction of 0.48 of the default next month was caused by the fact that this person belonged to the cluster 0, and the positive attributions were the values of outstanding balances and so on and so forth. I can have a look at the general driving factors of the cluster and of the general of the model as a whole. Then, if you want to dig in more and in more in depth, then let me just show you 2 of the other tools. So this is disparate impact analysis. For instance, this has already pre-selected the most prominent variable, which is sex. So you may wonder, is my model discriminating men or women, or members of given sex? So in this particular example, I'm having 2 sexes here, 0 and 1, and I can see that all my statistics are actually doing quite well. So I'm not seeing a particular drop for any of the two sexes in true positive rate, precisions, or other stats. So I'm able to, and actually this gets computed for me here. So I can actually have a look at these things in more detail, and I can also select other variables. Last but not least, here's my sensitivity analysis, which is a tool for debugging. This allows me to have a look maybe at the structure of my data based on let's see the age. So I will have the young, old, and mature, young, middle, aged, and mature. And you can see that actually in the middle age there is a more there are more negative, so lower amount of people that actually default. I'm also able to go ahead and filter and say, okay, maybe I want to also have a look only on people that are married. So I'm able to filter out and rescore, and now I will be able to see how the predictions changed, and so on and so forth. I'm able also to change the values of the given of any given variable in order to generate maybe some kind of adversary input, see if my model actually is or is not stable when someone starts testing it by sending maybe applications for credit loans with some random numbers, and see whether they can take the model down or not. So I would say this concludes the driverless AI tour. And now I will just pass the mic back to Stephen.
Awesome. Thank you so much, Stefan. Go ahead and share my screen. Cool. So as Stefan just showed, when we're utilizing these driverless AI nodes and sending them and running experiments, there's actually quite a lot of logic created behind the scene by the H2O data scientists. So for anyone kind of jumping in and wants to basically utilize their model as a service, it's a very simple process. So after all the kind of the parameters that he was able to show, if I want to kick this off from Knime, it's possible. And all I have to do is give it basically a data set, the target, the prediction task, and then these dials. So as he showed, these go up to 10. I put them as ones just so they would run faster for my demonstration, but they go up to 10 and could take a bit longer. Another really cool functionality from within Knime, if you want to actually hit the driverless AI user interface, you can do so within Knime. So if I go into this interactive view of the experiment node after it's been run, I can get a dialog window that takes me from within Knime to my H2O instance. And in the situation of this demo, I'm in Texas and this instance is in Europe. So it's actually a pretty seamless transition. I'll give it my information. And then once I sign in, I'm able to go into more details about these experiment that I just kicked off. So from here, if I want to look into the diagnostics, I can and basically do everything that Stefan just showed. So cool. So now we've gone over, so to recap what we've gone through, we built a workflow that is ingesting data from different sources, doing some pre-processing, sending the data up to a driverless AI instance for model creation. And now what we're doing is applying the model. And the last step is basically, okay, so I've created this model, now I want to use it, right? So let's try to get back to that initial workflow that I showed. So with Knime's integrated deployment, if I run this workflow with these purple sections, I can use the integrated deployment workflow writer node to automatically create a new workflow. So once I actually run this all the way to the end of this workflow writer, this is the workflow that automatically gets created by Knime. So I haven't edited this at all. This is just automatically created by the nodes that I did. So as you can see, what it's doing is it's basically creating a container or kind of an input and output where it's expecting some kind of data. It's going to go through those same pre-processing techniques, and then it's going to pull in the normalization. So as you can see here, there's two themes coming in. So we have the normalization model because we want the incoming data to be normalized the same way. And then we also want to apply the new model that was created. So as you can see, that's where these two port objects are coming from. So this is the normalization reader or model, and then this is the actual Mojo objects that was created. So now if I want to actually put this in production, it's a very simple process. All I have to do is basically take this model creation, deploy it to my server, and now we can see within my Knime server, I now have these three workflows. So what I have here is the model creation, which is what we're looking at now on my server. And what I've done is I've given it a schedule, and I told it, hey, run every single day because I want this, this new model to be reflective of the new data coming in. So I don't want it to get stale. So what I can do is run this every single day. And then this deployed workflow, which is the automatically created one, will be updated every single day that this model creation runs. So at this point, so to kind of finalize the demonstration, So I built this workflow with integrated deployment. I put it on my server. This workflow is creating the deployed workflow. And now from my local machine, I can go into this run against server, which I showed at the beginning. I can pull in some validation data. So once again, I'll show what I showed at the beginning. So this data has no context of a default in it. So it has no target. What I'm doing is I'm connecting to my Knime server. From within this node, actually is worth showing. When I connect to that server, I can go through and basically hit any of these workflows, and it's only going to work for ones that have that container input. I want to execute it. I should now have the results. So if I go to the output, I now have data with the prediction and probabilities of my different predictions. So to wrap everything up, what I did is I made one workflow that creates a deployed workflow, and then I've hid it from an external application. So within this context, it could be a different application, it could be a separate workflow, but essentially I let it create itself. So that concludes the scope of what we were going to show today. There's one question I saw: if running an experiment takes longer, am I able to inspect the progress and what it's doing from within Knime? That's a good question. Since the way they're designed, since it's actually pushing the execution to Driverless AI, you'll have to, if you want to see how it's progressing while it's running, you'll have to be in Driverless AI. But whenever it's finished, I'll go back to this actually, that's worth showing. Whenever the experiment's finished, we have two outputs here. The first one is going to be the experiment summary, and the second one is the actual model object. So the experiment summary will give me more details about how the experiment was run, so such as accuracy, AUC metrics, F1 scores, etc. And then if it was a regression, I'd have other details. So the short answer is you'd have to go to DAI to see it in progress, but once it's finished, it does send you back diagnostic information.
So maybe there's something useful. I'm not saying that it's super nice user experience because it does not have a clickable UI, but it's also possible to see the progression of the experiment in the log in the console. So if you just kick off a new experiment, it would be writing out to the console, and you can actually see the progress being outputted there. So I don't know if your setup can easily show the console. Sorry to put you on spot.
Yeah, let's have to reset this. I have to. I guess we can show it in action. So this is good to show because it does take a second sometimes for the transmission of data. So like I said, we're passing data across the Atlantic, which is quite a feat to take a minute. So, and then you want me to open the console.
Mm-hmm. And I'm not sure if you have the right set up the right log level. Yeah, maybe.
Do I have to have debug on?
I think info. And actually, someone is debug or info.
Okay, so live demos are fun, but so I'm guess the answer I'm getting is we have to turn on the debug option. So that's a pretty quick fix. But if anyone wants more information on that, just feel free to reach out to either of us. Were there any other questions? Go ahead and check. Cool. So we're almost out of time. I guess to close things off, if anyone has any additional questions or is interested in this integration, whether you were interested in setting these up on Knime server and using the Driverless AI nodes, or actually getting some kind of trial with Driverless AI, feel free to reach out to either of us. Our information should be on the summit page. You can find me as I'm Stephen Rauner, and I'm with Stefan Pacinda. He should be on the actual presenters list for this breakout session. So cool. Well, thank you guys very much for attending. I guess we can kick it off. And actually, sorry, I do have 2 more slides to show. For anyone who wants more information about this integration, we have a few blog posts here. You can find them on the Knime blog page or also the H2O blog page. These will go through more documentation on how to get this system set up and how to kind of work through and create the example that I showed today. So cool. On that, thank you very much.